Assalamu alaikum. So myself Mohammed Abdullah, and today I am going to present line folder which I made 2 weeks ago, and my team members were Reman Shafi and Mohammed. So I did it under company Mecha FUSE. That's my own company. I own it, and this is the final look of my line folder report. So moving toward the report. This is a table of content, abstract to objective, introduction, components, working principle, then our truth table, K-map, and then from K-map we will create an equation. And we also pasted a block diagram which we created it for rough review of what we are going to make from top to bottom. And then our Proteus layout, PCB from Proteus, and final look which we made it. And then our bill of materials, how much cost or what to make this line folder, and then resultant conclusion and references from where we collected the data and mixed up everything to make our own line folder. This is the abstract, you can read it later. Basically, we have used L293D IC as a motor driver IC, and 300 RPM motors as the current and voltage supply is too much low due to L293D requirements. We needed to only to give 5 volts, so it will use a lot of current because L293 will require a lot of current. That's why we use N20 motors. Because these are gear motors, it doesn't need too much voltage for high torque. It can generate its own torque with low voltage even because it's a gear motor. Then we have used 5 IR sensors in a single array, and these ICs and or not. 7404 is a not IC and or IC. So moving toward the working principle. So working principle is simplest. We have actually joined, you can see in this block diagram that last two sensors and first two sensors are combined together and creating a single logic. And working on it, first two sensors and last two sensors are acting as the same sensor. So the logic was just to follow the white line. We have connected second end of the motor, second and both motors with the ground. So our motor can only move in clockwise or only anti-clockwise. No, sorry, it will only move in clockwise, only in one direction actually, because it also can have more logic, but it can make our work harder because we then need four outputs, 4K maps, and that's a little bigger stuff. It will take a lot of time. So it's our project. We don't work a lot on it, but still, let's move ahead. From this truth table and K-map, we made these two equations, which will gonna follow white line. This is our Proteus layout. Maybe it should run. No. So let's leave J117. Now it will gonna run. And yes, it's running. So we off this sensor, left sensor and left motor will be off, and motor right will on, and it will move in this direction. This. So it's the way our robot will gonna work. We'll follow white line. This is our PCB layout, and this is our 3D layout. In 3D layout, these are the motor connections. These we will drill and add motor brackets and totem brackets here, which will be hold here using screws and nuts. These LEDs are in parallel with the motors. For example, this LED is parallel with this motor, which will be here. I think this is right of my hand, and this will be the left, and in parallel with this motor. These are the pins for 5 IR sensors. I plan to place the IR sensor below because this is a single layer PCB. So we will connect the upper pins to here without soldering because we have to use the sensor later, so we are not going to solder it. We'll use it later. We will disconnect it and we'll disassemble and use the thing later. That's why we didn't solder motors, because there's no need to solder motors with your PCB or something else. So moving to our to head, this is our printed document which we have pasted by after mirroring and then pasted it on PCB. This was the look when we pasted it on PCB, and this was our etching look. Here are the nuts and screws for and 20 motor brackets. There are two motor brackets used because two motors are used. We have already discussed why we use N20 motors not in place of DC motors. So these are the reviewing connections. We were reviewing the connection using light on the back. As in fiber PCBs, we can easily identify there is a misconnection. For example, if I zoom in it, here is a connection which were in contact. So we use a sharp blade to disconnect these and to make our PCB working. This was the final look, which was pretty well. We have donated. You can see we didn't solder the sensor as we already discussed. We will use it later. We can disassemble it. And this was the bill of materials. So our total cost was too cheap. That's 3,320. That's a separate case. We have used lot of experiment. We have did lot of experiment which it cost around 6,006K. So that's a lot of budget, but still the real budget is this because we have to pay the final budget. This was a result in conclusions. And we were lag in making PID line for because it was the complex work. Even without PID, this was also complex, and it's working better because I can show you a video. You can see here. So you can see that answer that's better and like a normal line follower. There's no need of PID. Yeah. So thank you guys. Back to another video. Anyway, bye bye, tata. Allah Hafiz.